Hello guys, let us now discuss Boolean algebra, its identities, and use it to find the DNF and CNF of the given function. Very first, double complementation law. Complement of a complement is the number itself. X bar bar is X. Idempotency laws, X plus X is X and X into X is also X. This is known as idempotency. When the number is added to itself, the number remains the same because we are in binary. We are talking about Boolean. Okay. Identity laws. X plus 0 is always X and X into 1 is also X. 0 is the identity for addition and 1 is the identity for multiplication. This is the meaning. Then we go for dominance laws. X plus 1 is equal to 1. 1 is the highest of all. So whenever you add 1 to any number, the highest number appears. And 0 is the lowest of all. So x into 0 is 0. This is known as dominance laws. For addition, 1 is the topmost. X plus 1 is always 1. And x into 0 is always 0. Commutative laws. Addition is commutative, multiplication is commutative. Associative laws. Addition is associative, multiplication is also associative. Then distributive laws. X plus y into z. So whenever we are talking about x plus product of 2, at that time you can have x plus y into x plus z. So this plus distributes over dot. I repeat, x plus y into x plus z. And talking of multiplication distributing over addition, this is not actually ordinary multiplication. We call this a supremum and infimum. So x into y plus z will be the same as x into y plus x into z. Then De Morgan's laws. De Morgan's laws are quite well known to us. De Morgan's laws. Complement of the sum is product of the complements. I repeat, complement of the sum is product of the complements. And complement of the product is sum of the complements. Complement of the product is sum of the complements. Then absorption laws. If you add x and x into y, sum is x always. So x is repeating over here, you can see x plus x into y will be always x. And x into x plus y will also be x. Lastly, we will deal with unique property. X plus x bar. X plus its own complement is 1 and x into x bar is always 0. So these are the basic properties which we will be using in CNF and DNF. So now let us deal with two questions based on CNF and DNF. The first question says, find the DNF of f of x comma y comma z equal to x plus y bar in bracket x bar plus z. So we have taken our function. What is this DNF? It is called as disjunctive normal form. Means what? You should write the function as a disjunction of brackets. And what the disjunction of brackets will contain? Either x, y or z or their complements. So inside the bracket you should have their complements. That is known as disjunctive normal form. Inside the bracket you should have conjunction and the brackets will be connected by disjunction. This is what we mean by DNF. Disjunction is plus and conjunction is product. Alright, let us go. So here we are having x as single plus y bar times this x bar plus z. So what we'll do, this multiplication let us distribute over this addition. So you can see here y bar into x bar plus y bar into z. So this is the splitting which is given by the distributive laws. I repeat, x kept as it is. You are applying distributive law here. So y bar into x bar plus y bar into z. Now here x is all alone. We have to bring the remaining variables over there. So I'll read this x as what? X into 1. We'll use identity law. So 1 can be written as y plus y bar. We want to bring y in picture. This was x into 1. So 1 we will write in terms of y. What way? Y plus y bar. So this x now is written as x into y plus y bar. Now going back here, multiplication is commutative. So I can read it as x bar into y bar. And I want z also in picture. So let me read it as into 1 as we did in this case. We read the number as the number into 1. Same way here also. We read this particular as the number into 1. So we have written x plus x bar, that is 1, into y bar z. This is unit property we have used. Next step, x into y plus x into y bar. We have distributed this multiplication over addition. Then this one, now we are writing using our unit property as z plus z bar. X is there, y is there. We want to bring z in picture, so we are taking the help of this one. So we have written this as x bar into y bar, which was already there, into z plus z bar. Here this multiplication distributes over addition, so you'll have x into y bar z plus x bar into y bar z. So that is very common distributive laws. Now x into y is there, but there is no z. So we will read it as x into y into 1. That into 1 is written as z plus z bar because you want to bring z in picture. So you write it as into 1 and that 1 is written as z plus z bar. So you are having xy in bracket z plus z bar. Again here also you don't have z. So to bring that z, you'll read this as xy bar into 1. So that one again I'm writing as z plus z bar. Going next, here x bar y bar is there. Let us multiply this inside. So we'll have x bar y bar in bracket z plus z bar. We will open it later. Going here, these terms are copied as they are. Now let us open this. X into y into z we have written first. Then comes x into y into z bar. Then x into y bar into z. Then x into y bar into z bar plus coming here x bar y bar z, you can see. Then x bar y bar z bar. Then comes x into y bar z, and this is x bar y bar z as it is. Now what you observe in this expression is this term x y bar z and x y bar z is repeating here. We have shown it by yellow underline. And x bar y bar z, the pointer is here. X bar y bar z is repeated here. So that I have shown by green line. So you can see the number added to itself is the number itself. So instead of writing this twice, we will write it only once. So see, this xyz I have taken plus xyz bar I have taken. This instead of writing twice, we are writing only once, plus xy bar z bar plus this is again twice, that we will write only once, and this term we have taken. These terms were repeated, so we are not taking them again. So this is nothing but the DNF. Now how to get, the DNF I have rewritten. Now how to get CNF? CNF is the complement of DNF. Complement means whole bar. Now what this bar does? By De Morgan's laws, complement of the sum is product of the individual complements. So complement of the sum now becomes product of the complements xyz whole complement, xyz bar whole complement, xy bar z whole complement, xy bar z bar whole complement, x bar y bar z whole complement, x bar y bar z bar whole complement. So you can see complement of the sum we have written as product of the complements. Now here this is complement of the product, so it will be sum of the complements, so we bracketed it. This will be sum of the complements, or otherwise let us denote it by brackets, that will be helpful to all. So I would like to bracket it. You can see, if you don't put the brackets will also do, but if you put the brackets over there, the things become more clear. So I would like to put brackets over there. Okay. Now inside this bracket, what you observe, this is complement of the product. It will be sum of the complements. Again here, complement of the product, it is sum of the complements, x bar, y bar, and this will be z bar. Bar means z back. Here complement of the product we have written as sum of the complements, it will be x bar, y bar, bar means y, z bar. From this bracket we will have again the same way, x bar into y into z. This will be x, y, z bar, and this will be lastly x plus y plus z. So this is the conjunctive normal form, which we call as CNF. One more question, let us practice for DNF. It's a small question. Here we are having only two variables, x and y. Earlier there were three variables, here we are having only two variables. Okay, let us go. F of x comma y is x bar plus y given to us. So what we need to do is, near to x bar we need to bring y, and near to y we need to bring x. So what we do is, we read it as x bar into 1, and this we read as y into 1. Which law we have used? Identity law. Then 1 I can write as y plus y bar, y for, because I want y there. So we are writing y as, 1 as y plus y bar, and this one we will write as x plus x bar. Now let us open it. So this will be x bar into y plus x bar into y bar, as we have done here. And this will be y into x, but by commutativity I can write it as x into y. This will be x bar into y using commutativity. So what I observe is, x bar into y is twice, so the sum is ultimately x bar y. This term x bar y bar as it is, and this term xy as it is. So this is the DNF. Now let us go to the CNF if you want. This is just for practice. They have asked only DNF, so I have written DNF. But for your practice, I am giving here CNF. What is CNF? It is the complement of DNF. So f of x, y, z, its whole complement. Now what happens? This is the complement of our earlier got thing. So this whole I have written inside the complement. Now complement of the sum, is product of the complement. So we have written product of the complements, individual complements. Now inside, complement of the product is sum of the complements. This will be x bar bar meaning x, and this is y bar. Again here inside, complement of the product is sum of the complements. Both were already complements. Their complements will be the numbers themselves. And into again the same way, xy whole bar will be x bar plus y bar. So this is known as CNF. This is conjunctive normal form. Now, I would like to take you to the Hasse diagram. How to draw Hasse diagram? Let us practice. So basically, we will be dealing with the relation of divisibility. The question says, draw a Hasse diagram for D30. What the set D30 indicates? It is the set of all divisors of 30. What are the divisors of 30? So as we all know, 1 divides every number, 1 is there. 30 is even, so 2 is there. 30 is divisible by 3, 3 tens are 30, we know it is there. 5 6 are 30, 6 5 are 30, we all know. 10 3s are, 5 2s are, 15 2s are, sorry, and 31s are. So all divisors we have listed. Now what we have to do is, we have to write their precedence. So we know 1 divides 2. So between 1 and 2 there is no other divisor. So we have written 1 precedes 2. 1 precedes 3. 1 precedes 5. Now go for 2. 2 precedes 6. There is no other divisor between 2 and 3 or 6. There is no other divisor between 2 and 10. So 2 precedes 10. Same way we have written 3 divides 6 and 3 divides 15. 5 divides 10, 5 divides 15. There is no other divisor, so we call it as precedes. Lastly, 10 precedes 30, 15 precedes 30, and one thing I forgot to write here. What is that? 6 also divides 30. There is no other number between 6 and 30. I suppose you are getting. Now, this precedence, how do we indicate the precedence? So this is the indication. This is just for your understanding. You don't write this. If you write, nothing is wrong, but no need of writing this. You can see 1 divides 2. So the level of 1 is to the lower side and 2 lies to the upper side. Whereas 2 doesn't divide 3. So 2 and 3 are not comparable. Whenever two numbers are comparable, the lower precedes the higher. This is the thing. So 1 precedes 3. 3 is to the upper side, 1 is to the lower side. 5 is to the upper side, 1 is to the lower side. But 2 and 5, they are not connected. They are not comparable. Same way here, 2 precedes 6, 2 precedes 10. But 6 and 10 are not comparable because 6 doesn't divide 10, neither 10 divides 6. Same way here you can observe the rest and have to combine all this. So you can watch here. What we have done, first step we have written 1 to the lower side. Bit higher 2, 5 and 3 are arranged. Bit higher 10, 6 and 15 are arranged. And lastly, at the topmost position you are given 30. Now what you can see, 2 and 5 both divide 10, so we have taken 5 in the middle. 3 and 5 both divide 15, so they are taken to this side. And the 6 is divisible by 2 and 3, so it is taken in the middle. So as good as a diamond shape we have tried to give. So the thing becomes readable, easy to understand. Then 10 divides 30, 6 divides 30 and 15 divides 30. So this is nothing but the Hasse diagram. Okay, so you can see this is bit combination of these branches that I have shown here. So these branches are taken together to draw this particular Hasse diagram. I think again I haven't shown 6 and 30, so I need to show 6 and 30. Wait a minute, I would like to go with 6 and 30. So 6 is here, 30 is here, 6 is to the lower side, 30 is to the higher side, and as you all know, 6 precedes 30. So all those things we have combined in this diagram. Now I would like to go with the next question. If any random set is given and we are asked to draw Hasse diagram under divisibility, how to go? Again you go with the precedence. 1 divides 2, 1 divides 3, 2 divides 4, 4 divides 8. 2 also divides 8, but between 2 and 8 you have 4. So this is known as precedence. Between 2 and 4 there is no other divisor in this set. 4 and 8 do not have any number in between them. So this is known as precedence. So how to draw it now? You can see 1 is at the bottom, 2 and 3 are a bit higher, 4 is higher than 2, and 8 has the highest position. And you can see 2 and 3 are not connected, neither 3 is connected with 4 nor with 8. So this is the Hasse diagram. I hope this will be quite fruitful to you. So keep practicing and all the best.